Hello everyone, I am Mr. Sagar de Bhopale, working as an assistant professor in Department of ENTC of AISSMS, IOIT Pune. In this video, I am going to tell you something about types of systems. So what is system? A system is a physical device that performs an operation on signal. So the input signal is given to the system. System will process that one and it will give the processed output. Input signal is denoted by either x of t or x of n, and output signal is denoted by y of t or y of n. There are mainly two types of systems. First one is continuous time system. So for continuous time system, input as well as output both are continuous time in nature. Examples of continuous time systems are analog filters, amplifiers, attenuators, and discrete time systems. So in discrete time systems, the input as well as output both are discrete in nature. Examples of discrete time systems are computers, printers, microprocessors, etc. Next point is classification of systems. So systems are classified into different classes shown in this slide. We will study one by one in detail. First one is lumped parameter and distributed parameter systems. A lumped parameter system is one in which the dependent variables of interest are a function of time alone. So the dependent variables are generally shown on y-axis and independent variables are shown on x-axis. So if the dependent variables depend on the independent variable, which is time, and if they depend on single independent variable, then that type of systems are called as lumped parameter systems. These are described by ordinary differential equations. Examples of lumped parameter systems are y of t is equal to x of t plus 2. So this system depends on a single parameter, that is t. Therefore, these type of systems are called as lumped parameter systems. Next class is distributed parameter systems. In distributed parameter systems, all dependent variables are functions of time and one or more spatial variables. That means here independent variables are more than one. So these systems are described by partial differential equations. Now, example of this one is system Z depends on two independent variables, that is t and p. Next class is static and dynamic systems. Static systems, in static systems, output depends only on present input and there is no need to save any past input or future inputs. Therefore, these systems don't require memory. Therefore, these systems are called as memoryless systems. Example of it is phi is equal to R into I. That is, output voltage depends upon present current. Therefore, these systems will not require memory and these systems are called as static systems. Next class is dynamic systems. So in dynamic systems, output depends on present input as well as past or future input. So here we have to save the past inputs. Therefore, this type of systems require memory. Therefore, these systems are called as system with memory. For example, y of n is equal to x of n plus x of n minus 1. That means output y of n depends on present input as well as past input sample. Therefore, this system is called as dynamic system. Next class is causal and non-causal systems. So causal systems, in causal system, output depends only on present input, past inputs or past outputs, but not on future input or future output. That means in causal systems, output will not depend on future input or future output. So these type of systems are called as causal systems, and the example is y of t is equal to x of t plus x of t minus 1. Here we can observe that output depends on present input as well as past input, but not on the future input or output. Therefore, these systems are called as causal systems. Next one is non-causal systems. If the output at any instant depends on future input or output, then it is called non-causal system. Example of it is y of t is equal to x of t plus x of t plus 1. That means here the output depends on present input as well as future input. Therefore, this type of systems are called as non-causal system. Next class of systems are linear and non-linear systems. So linear system. A system is said to be linear if it satisfies superposition principle. So what is superposition principle? Here, if we assume that inputs are x1t and x2t and the corresponding outputs are y1t and y2t, that means y1t is equal to system applied on x1t and y2t is equal to system applied on x2t. So then a system is linear if it satisfies the condition system applied on a1 x1t plus a2 x2t is equal to a1y1t plus a2y2t. So if this condition is satisfied, then that system is called as linear system. For example, y of t is equal to t into x of t. So this system will satisfy this above condition. Therefore, this system is called as linear system. And a system will be called as nonlinear system if the above condition is not satisfied. That means if this condition is not satisfied, then that system will be called as nonlinear system. Example of it is y of t is equal to a into x of t plus b. Next class is time variant and time invariant systems. So a system will be called as time invariant system if the time shift in the input signal results in corresponding time shift in the output. If, for example, if x of t produces output y of t, then x of t is input and y of t is output. Then if x of t, that means input, is delayed by time t1, then output y of t will also be delayed by the same time. That is, if we make the changes in the input x of t by x of t minus t1 and it is applied to the system, then output will be also affected and output will be y of t minus t1. That means if we make the changes in the input, if the same changes occurs in the output time also, then that type of systems are called as time invariant systems. Example of it is y of t is equal to x in bracket 2t. So this is the example of time invariant system and it satisfies this condition. So these type of systems are called as time invariant systems. Then time variant systems does not satisfy above condition. They will not satisfy above condition. Therefore, that type of systems are called as time variant systems. Example of it is y of t is equal to t into x of t. Next class of systems is stable and unstable systems. So stable system satisfies BIBO condition, that is bounded input bounded in output condition. That is, if the system produces bounded output for bounded output, if the system produces bounded output for a bounded input, then the system is called BIBO stable system. Example of it is unit step signal. Then unstable system. If the system produces unbounded output for bounded input, then that type of system is called as unstable system. Example of it is ramp signal. Then last class of systems are invertible and non-invertible systems. So invertible system. If the input can be recovered from the system output by cascading output to the inverse system, then that type of systems are called as invertible systems. For example, if input is given to a system, input x of t is given to the system, it will produce the output y of t. And that output, if we can apply it to a invertible system, and if such invertible system exists, so that if output of the system y of t is applied to that system and if it gives the original input, that is x of t, then that type of system is called as invertible system. So if the above condition is not satisfied, then the system is non-invertible system. So these are the different classes of systems, and for this video I have used these references. Thank you.